This video we are actually looking at crashing an event, and you need to know the reason why would you crash. Is it how long maybe a project would take? So usually you have a project length, okay, then you've been asked to crash that project, or by how much can you reduce the time period that this project will last. They're basically asking you about what? Crashing that project, reducing the project length. So that's basically the reason why we crash. And there are certain steps you need to take, which this video will highlight and get to show you the procedures that you need to know about crashing. Yeah, so once you just get the procedures, it's very straightforward, trust me on that one. So I will explain step by step what you need to know when you're crashing an event. So one of the steps maybe I can just state before we actually look at the question is, before you crash an event, identify the critical path. It's usually very key, because what we crash is the critical path. Why the critical path? Well, if you still recall in you just say in the earlier video that I had already made on the critical path method, the critical path identifies you the length of the project, because that is what you use to determine the length of a given project. That is why we crash based on the critical path. So let us look out for a question, of course, and then get to understand how you would crash and the like an event. So suppose you have a question like this given on the screen: activities, maybe the normal duration and cost, of course, crash duration and cost. First of all, the first thing is draw the network. Okay, you draw the network. After you draw the network, what next? Determine the critical path, because we said we crash based on that critical path. So let me share a screen on how you first draw the network, identify your critical path, and then from there you pick it up and start the crashing process. So that's your network. You draw the network. Then what next? Identify the critical path. So in this video, I'll just show you a shortcut method of getting that critical path rather than using those tables that were used in my earlier video of critical path method. Okay, this one is where you just like test out all the routes and find the one which has the largest number, right? Because critical path is the longest route in the network. So you have 1 to 2, 2 to 5. It's a possible route giving you what? 18. 1 to 2, 2 to 4, 4 to 5. What does that give you? You get about 13. What about 1 to 3, 3 to 4, 4 to 5? What does that give you? 12. Well, we had the largest figure we just had, 18. So 18 becomes your critical path, which is 1 to 2, 2 to 5. We will base our crashing based on this critical path. So first of all, when you're crashing an event, first of all, you remember the table I shared. There was the normal duration, the cost, of course, and the crash cost and the like. First of all, you get back to that table and create the following columns that I'm going to explain very soon. Okay, to get first of all the overall costs. Okay, the overall costs of completing this whole project. Okay, the whole project meaning for the whole network path that you're seeing here. I'll explain very soon with the next screen. So this screen that I've now shared with you is like that table we started with in the initial part of the video when I showed you the question. What we're only adding to that table is 2 new columns, and please identify them. That is the crash limit column and the cost per day column. These are very important, because when you're crashing, you want to even be determining how costs will be varying and increasing, okay, as you crash a project. Crash limits, how do you get all those figures? I'm about to even explain on the next screen how you get the crash limit, how you get the cost per day, which they would also call the slope, okay, in some books. Yeah, this is just basically that, okay, if you reduce 1 day to the project, the cost of so much will increase. That's what they're just meaning in here. You increase another day, the cost doubles, just something like that, if anything. So let me just share how you get the crash limit and the cost per day, because these are the new columns that are even very key for what? Crashing a project. Let's start with crash limit. What is crash limit equal to? Crash limit is equal to what? normal time minus what? Crash time. These will always be given in a question, just look out for them. Normal time minus crash time is crash limit. That figure you get, for example, if it gives you 2, what does that 2 mean? Meaning you can just reduce an activity. Maybe if there was an activity 1 and 2 in that particular figure you found of crash limit 2, meaning that project in that line can only be reduced by 2 days. That's all. So that just simply means. How about the cost per day, or what they would call the slope? So cost per day is actually solved by doing what? Crash cost minus the normal cost. I'll just abbreviate normal cost over what? Sorry, let me just do that. Normal time. Okay, normal time minus crash time. Actually, that's the formula for getting that cost per day you are seeing there, and actually the slope, or that's the other name. So you've done that part. You create that table as earlier shown in the screen. Okay, but what are we crashing? The critical path. Take note of this. So me, what I've done is that I've just taken even an extract of the table and just focused on the crash limit and the cost per day of just the critical path, because that's what you're crashing. That's your main focus. That part, we just take the whole summation of the table. Why? One, first get the overall cost of completing the project in all those ways of that network, right? You sum up everything in the if anything, you have to sum up everything in the normal cost column. I'll just share the screen again so that you understand what I'm trying to say. Then I'll show you how we begin the crashing process. So first of all, we said, why are we creating this table of some sort, where there's crash limit, of course, and the cost per day, which are key. First of all, we want to know, first of all, the overall cost, first of all, of this entire project, having all those activities, right? Having to do all those activities. It's focused on this. I'm zooming it in, the normal part of this table, the costs part, if anything, specifically the normal costs, sum them up. That is the overall cost of doing all the activities stated in the question. If you add up that, it will give you 540. So what will happen is that as you crash, so sorry, 580, sorry. So it's like, what happens is, as you crash your activities, this cost will increase, because they said that the cost per day of crashing, because if you crash minus a 10 day, the cost will increase. That's what happens. Time period is reducing, but cost is going up. Okay, that's what's happening. So you're like on 580 first overall, you're crashing maybe a certain activity. That cost will increase based on the cost per day that was in that column, and it will be making sense as we move. Basically, that's what will be happening. So as earlier mentioned, I said I've made an extract of that whole table, because first of all, our focus is what? The critical path. That's how we usually crash. We crash on the critical path. So we have what? Critical path 1 to 2, 2 to 5, if you remember the earlier part of the video. Okay, get the crash limits, because we said these are very key when you're crashing an event. Crash limit, and of course the slope, or the cost per day, as other books would call it. So what will happen is that, okay, activity 1 to 2, it can be crashed only by 2 days. In other words, activity 1 to 2 can just be reduced by 2 days. That's all. So that just simply means, so if it was on 8, why should you end? 6. That's all. Activity 2 to 5 can be crashed by what? 5. That was the limit there, and we've already explained how to get the limit if you rewind the video. So that also means you can just reduce activity 2 to 5 by what? 5 days. That's all. So you have to crash all these 2 activities, because they're along the critical path. You want to see by how much you can actually reduce this project length. So what I'm going to do is, okay, this is what I'll do before you start, of course, reducing the activities. There are 2 of them, 1 to 2, 2 to 5. Which one do you start with? There's always a procedure. You just don't pick any. No. What happens is that we look at the cost per day part. Which of those has the least cost per day? It's activity 1 to 2. That will be the one that we will start with in terms of crashing. Okay, so let me share a screen and illustrate all this. So if anything, this was your network, right? We're beginning to crash the process. We said we start by crashing the activity having the least cost per day, which was activity 1 to 2. So they said the furthest you can actually reduce that is based on the crash limit, only 2 days. So if it's on 8, we should only end where? On 6. So I've crashed, okay, 1, I'm getting 7, right? From this point, what next? Determine the critical path again. It's like for every day you crash, determine the critical path, just like that. It's like a procedure until you're done with the limit where you end up. So like you do the critical path for the whole network. You start determining which one will be the critical path. You just know that it's the longest network in the longest path in the network. So of course you have a 17, 1 to 2, 2 to 5 is now 17, 1 to 2, 2 to 4, 4 to 5. There you now have what? That's 9, 12. 1 to 3, 3 to 4, 4 to 5. That's a possible route, giving you 12. The longest path, it's still the same one apparently. So you just keep it like that, because you only crash on the critical path. So you go back, the same picture. The critical path is 1 to 2, 2 to 2 to 5. You're about to start crashing. Apparently we said it's the same network. When you're starting to crash, which one do you start by crashing? The activity having the least cost per day. And apparently since it's the same one, we get back to activity 1 and 2. So we've already crashed it by 1, and it should end on 6. So they told us, because the crash limit is 2. So reduce it further. You're now on what? You're on 6. Okay. Redetermine the critical path. Just again, the process just repeats itself. You start testing out again. So you have, maybe you get like now a 16. This time around you have what? You check 1 to 2. That was 1 to 2. 2 to 5 gives you 16. 1 to 2, 2 to 4, 4 to 5 gives you, that should be about 11. The other route, 1 to 4, 1 to 3, 3 to 4, 4 to 5 gives you still 12. Okay. Look at your paths there, right? Again, the longest, apparently it's still the same path. 1 to 2, 2 to 5 still remains your critical path, right? Okay, it's still the critical path. You look at it. Can it still be crashed any further? Yes. Although activity 1 and 2 has now been what? Eliminated, because it has reached its what? Its limit. You cannot crash it any further. Meaning your attention shifts to what? The other one that you are not crashing initially, but it's still along the critical path. And which activity is that? Activity 2 to 5. Let me just share the table so that you get to see activity 2 to 5's cost per day. So activity 2 to 5 is still in the critical path, okay? Of course, that's a cost of 60, right? Okay, that's the cost of 60. Then, of course, meaning we have to crash it at a limit of 5. So the limit of 5, meaning we should, whatever number which is on activity 2 to 5, we should only end when we have reduced about 5 days or so, right? And if I remember, there was 10, meaning we're going to end where? On 5, because we're just 5 days behind that 10. So one thing I just did not mention as well, crashing. Let me just illustrate it back to the same question quickly. So, but of course, our attention is now shifting to 2 to 5. Why? Because 1 and 2 has been exhausted until its limits. So the other activity on the critical path is 2 to 5. And as long as an activity is on the critical path, the crashing process continues. So one thing I was forgetting to mention, okay, it's like when we crashed to 7 days, right? From that first one, 1 to 2, we reached 7, right? What we're supposed to do is that when you just crash once, determine the cost. We said the overall cost of all the projects is 580 when we started the video, and you remember we got that 580 rewind. Then they told us that the cost per day, if you are crashing maybe a particular activity, they have their costs per day, right? And for 1 and 2, it was what? 50. Okay, so you keep adding. The more you crash, the cost goes up. So it will be like from when we reached on 7 days there as the first crash, it gives you a cost of 630. Okay, that's the first one. We went further and crashed it again by another day. Okay, we were on 630. We've crashed it by a further day again, right? This just does what? This will just simply mean that, okay, 630 plus another 50, because apparently we're still on activity 1 and 2, and they said the more you crash that particular activity, the cost per day will just keep increasing by that particular cost per day. So this will now lead you to 680. That's what you now have. Okay, and that's where 1 and 2 was exhausted, and our attention shifts to the other activity. As long as you're on the critical path, it has to be crashed. So let's now move to activities 2 to 5 at this point. So Just some stuff has to be erased on the screen, and then just erase the whole network and redo it again so that you can get to see these things we've been doing clearly now. Okay, this one has already been reduced to now 6. Just drawing a cleaner network if anything, because it can get a little bit messy as you have noticed. Yeah, so there's supposed to be 4 there, and of course there was that number, there was a 2 there, there was a 3 here. Okay, then we are interested in the activity up there. Actually, this activity just here, let me just put those the other numbers there. Okay, we're interested in 2 to 5. It's on the critical path. Start crashing it as well. The crash limit on that activity was what? 5, meaning that 10 has to, when you have to stop when it reaches 5 days. So you start. Okay, -1 gives you what? 9. Determine the critical path. Just whenever you crash, determine the critical path. It's a process. 1 to 2, 2 to 5, giving you what? 15. 1 to 2, 2 to 4, 4 to 5 gives you what? That's 11. 1 to 3, 3 to 4, 4 to 5 gives you 12. Okay, you have your figures. The longest route apparently is the same one. You only crash where? Critical path. That's all. Those are the routes. Get back to the same critical path. Which one are you crashing? Apparently it's still 2 to 5 because 1 and 2 has already been exhausted. So we reduced that 9 on what? 8. But just before I go to 8, we said for every day you crash further, cost is going up. So we are currently on a cost of 680. It's increasing. The more you crash, you're increasing the cost. On activity 2 to 5, the cost per day, if you rewind in the video, was 60. So for that first day you've crashed, add on 60 to this. What does this give you? 740. Okay, you're on 740. Okay, let's crash it to now the 8th day. That's what we are now. Determine the critical path once again. So okay, 1 to 2, 2 to 4. So 1 to 2, 2 to 5 is 14. Okay, you have 14. I'll write the figures on the left side of the screen. 1 to 2, 2 to 4, 4 to 5 gives you, okay, the same figure, 11. 1 to 3, 3 to 4, 3 to 4 to 5 gives you 12. Longest route apparently is the same one. So determine, of course, you determine the critical path, the longest one, 1 to 2, 2 to 5 apparently. Get the costs because you have now crashed to 8 days. The cost of activity 2 to 5 per day is 60. You're on 740. 740 plus 60 is what? 800. We're moving just like that. Okay. Go to the 8. Reduce it. 7. 6 to, okay, 1 to 2. 2 to 5. What's the figure? 13. Again, you go through the other routes. 11. The other one gives you 12. The longest, 13. Okay. It's 13. Okay, you're done there. What next? You even put the critical path is still 1 to 2, 2 to 5, still the same one. Go further. Okay, you're on 7. Just before we go further, add on the costs. Whenever you crash by a day, the cost increases. You're on 860. We are moving. Get rid of this 7. You're now on 6. Determine the critical path. Okay, that one gives you 12. Okay, the other one will give you what? Okay, that's 12. That one gives you 1 to 2, 2 to 4, 4 to 5. That one gives you 11. 1 to 3, 3 to 4, 4 to 5 gives you 12. Apparently, they're the same on this one. 2 critical paths. Okay. Okay, so first of all, you're on day 6. Okay, I've identified that yes, we have 2 critical paths, but of course, first let's increase that cost as of day 6. You are on what? You had reached 860 plus another 60 because that route activity 2 and 5 have a cost per day of 60 that keeps increasing, which leads you to 920 as at now. 920, right? Okay, the crashing process is obviously not done, and we have 2 critical paths. What do? Well, first of all, finish off this one, the one you started with, which is still a critical path apparently, and the other one you come and shift your focus to it after, if anything, to see if your project can still be improved any further or not. So we were on 6. They said this route can be used to 5 days. Okay, go to 5 now. We're on 5. We determine your critical path 11, right? Okay, that one gives you 11. then the other roots gives you what? 6, 2, 3, 11, 1, 3 to 5 to 1, 3 to 4 to 5, 12. Okay, apparently there is now one critical path left. 1 to 3 to 4 to 5. Let me just erase the screen. There's been so much, but before I just erase, we've just reduced to day 5, so the cost has equally gone up. 920 plus 60, because this activity has a cost per day of 6, be giving you 980. Currently, that's your cost. Currently. So just erase the screen so that we shift our focus to the other critical path, because we only crash critical paths and see how best you can crash them. You only stop crashing when you reach the limits. That's just what I can just say about when to stop. So let me just erase this. Okay, so this was our diagram. 2, 5, 3, 4, and then there's obvious that was this. We had the 2, we had the 6, we had the 3, we had the 4, we had the 5 here. We had what? Haven't I just been swapped this? Okay, now it was 5, 4 there, and then the 3, and we had what here? 5 days. That was the limit. Okay, let's get back quickly to this question. Okay, sorry, just before we get back to the question, I was actually swapping. Here there's a 4 and here there's a 5, but don't worry, the number is still 12. If you add 1 to 3, 3 to 4, 4 to 5, it's still 12. I was just swapping the positions of activity 1 to 3. It was supposed to be 4 there. 3 to 4 was supposed to be having 5. Okay, just take note of that. And then, of course, 5 there, right? Okay. Then, let's get the question quickly. We have a new critical path. 1 to 3. 3 to 4, 4 to 5, because sometimes the new critical path can still emerge even as you're crashing, even though you just started with 1. So 1 to 3, 3 to 4, 4 to 5. As usual, when we're crashing, what do we look at? Cost per day and the crash limit. So for example, look at those same activities. They each have their cost per days and their crash limits, right? What helps us to know which one to start with? The one with the least cost per day on those in the critical path. So if you look at this one, the one having, is it 4 to 5? 4 to 5 has the least cost per day, which is about 10. That's the one you will begin with the crashing process. And let me demonstrate that. So your costs as well, don't forget we're currently on 980 as a cost. Okay, we said the activity is the least cost per day according to the new critical path is this one, 4 to 5. So reduce this 3 days, you're now on 2 days. Redetermine the critical path again. On top 1 to 2, 2 to 5, you have 11. There 1 to 2, 2 to 4, 4 to 5, you have what? This is 11 again. Okay, 1 to 3, 3 to 4, 4 to 5, you have what? 11. 3 11s, right? Okay, you have 3 roots having the same figure. Okay, first of all, let's just adjust the cost, 990. Okay, we're there. For example, let's just finish this path. As we said, even though another critical path has emerged, you first finish off the one you started with, and then of course you shift your focus to the other one. So if I get again this one at the limit of what, we should have checked this in the question so to know where this activity 4 to 5 should end in terms of limit, in terms of crashing. So activity 4 to 5, if you look at the crash limits, 2 days. It was on 3, meaning we should end on 1. So the next time we crash, then that will be the end, because then we've reached 1. So we're back on this screen. Okay, we are crashing. Okay, 1. Redetermine your critical path. Try to check. So you have what? 1 to 2, 2 to 5, 11, right? So, okay, 1 to 2, 2 to 4, 4 to 5, 11. Okay, 1 to 3, 3 to 4, 4 to 5, you have what? 10. That's reduced. Critical path, it's those having 11, right? The longest route in the network. Now you ask me, that one up there, if anything. Okay, so let me just redetermine the path. I've just realized there's some computation error. 1 to 2, 2 to 5. Okay, that's 11. 1 to 2, 2 to 4, 4 to 5. Count, that's 6 plus 2, 8. 8 plus 1, 9. Actually, 1 to 3, 3 to 4, 4 to 5 is what? 9 plus that is 10. Okay, critical path gets back to the original, the one we started with, right? What does this code to show you? The original one, right? We've already crashed it and it has reached what? Its limit, meaning the project cannot be reduced any further. We just stop there, if anything. Huh? Of course, critical paths are emerging, but the moment it ends up taking you especially back to your original point, then you cannot crash any further. Whatever cost you've accumulated, that is your overall cost. You just determine that, okay, my overall cost will now be 990, if anything, okay, because apparently we will not crash any further. From what we can just see, it has taken us back to the original point, and the original route has already been crashed. And if it took us to another route which has not been crashed, then would have proceeded. So basically, you didn't say since 11, you've been like, okay, now the days have been reduced to what? To 11 from where we started from, of the initial number of days, and that's it on crashing.